We are doing even and odd functions. Today is Wednesday. This video is will be taken up. The notes will be taken up Thursday in class. So take good notes tonight. Okay. The official definitions of even and odd functions are listed here. So pause the video and take good notes and write down what we would call the official definitions of even and odd functions. I want you to see this and read it and understand it. Then when we plug in a negative for a function to be an odd function, when I plug in negative for x into the function, I will get an entire negative function. And then for a function to be an even function, when I plug in negative for x, I would get out an even function altogether. So that is a lot harder than it looks. So what we're going to show you is kind of the easier way to tell if a function is odd or even. So we're going to be telling you two different ways. The first way that we're going to be looking at functions is algebraically. Okay, algebraically, and I'll show you an example of that first. But first, write these three points here. A function is even if all the exponents of the variable are even. Okay. A function is odd if all of the exponents of the variable are odd. Okay. We'll show you what that looks like in just a second. And then a function is neither. It's neither if the exponents are a mixture of odd and even. So if there's a mixture, if it's not all odd or all even, we say that it's neither. Okay. Here's a quick point: is to beware of constants. Constants. Okay. Beware of constants because they really have. This is really the exponent for a constant. When we say constant, I mean 8. Just like the number 8, it really has x to the 0 power. Or the number -3. It really has x to the 0. And we count those as even, okay? We count constants as even exponents. Okay. Now, 0 is not an even number, but we count it as even exponents. Okay. So next, let's talk about examples. So the example number 1, is this even, odd, or neither? And we look at the exponents. This exponent here is a 3. This is an imaginary 1, right? So both those numbers are odd. So we say number 1 is odd. Okay. Next, number 2, or example number 2. We have an even constant here, or an even number here. And what did we say about constants? That this has an exponent, or a variable and exponent of x to the 0 power. So we'd say that this is an even function. Okay? All right, the next way that we're going to look at even and odd is graphically. It's showing a picture of the function. And a function is even if the graph reflects across the y-axis. Okay. And then here's a little hint that you need to write down. Means if you can fold it hot dog style, then you could match it, and it would match up. So we'll show you what that looks like on the next slide. And then the next one is odd. A function is odd if it can be rotated 180 degrees around the origin, about the origin, then it's odd. So one way we look at that is if you could stick your pencil in the middle of the paper. If you have a piece of paper, stick your pencil on the origin and spin the paper around 180 degrees. If it would match up to itself, then we'd say that it is odd. Okay, next slide. Let's talk about this one. So even, odd, or neither. And we look at it and we say, does it have symmetry in any way? And if I drew a line down the middle, it would have symmetry. I could fold this side over, this side right here could fold over, and it will be on top of this side. So we say that this is even. If it has symmetry on the y-axis, it's even. Example number 4, we say if it has rotational symmetry, it has, or about the origin. So this is the origin right here, and this is neither. It looks like it could have odd symmetry, but it's neither, because if we rotated this around the origin, it would look something like this. It would come here and go back down. So it wouldn't have perfect, it would almost have rotational symmetry, but it doesn't. So here is a couple more examples. So let's do these examples together and see what you get. So this one right here, this example here has what we say as symmetry about the y-axis. So this is even. This right here has rotational symmetry. If I rotated it, this side would come onto this one. This would come back on the other one. So this, and it would be back over top of itself. And so we would call this function an odd function because it has rotational symmetry about the origin, right middle of the graph. Okay? And then down here at the bottom, it says even and odd neither, and it's asking us now algebraically, so we look at the exponents. This is an odd number, an even number. Since it's mixed, we say neither. This one right here is an odd exponent, and this is an imaginary one, so it's odd. So we say, since they're both odd, we say it's odd. And then this one is odd here, this is odd here, and this one, remember, we count this x to the 0, and it's even. So since it's mixed, we say neither. Since it's mixed, we say neither. Okay? So that is your video for today, even and odd functions.